Your microphone muted, but no signal. That's fine. Good. Oh, there, there. Okay, looking good. So welcome to the pre-stream. If you're here, we're going to probably in 5 minutes. I'm going to start up the LinkedIn stream, and then we'll let that settle for 5 minutes. But feel free to make sure you hear audio. Say hi in the chat. We can have a quick pre-chat session before we begin this live stream. If anyone has suggestions for future videos, it can be Altera or it can be another FPGA base. Any ideas of what you want to see? I'm going to try to start doing some more, I guess, development streams in the future and try to keep direct presentation, like a scripted presentation, but also kind of some unscripted development streams. Let me... Good way to check. Okay. Go ahead. Switch. Audio. Good. I think it should be transmitting. Definitely hear what's being transmitted. I guess I don't constantly transmit music, so the audio bitrate goes down, like to complain. Okay, we're gonna probably go live with the LinkedIn stream in a few minutes. Okay, the LinkedIn up and going. One viewer on there. Kind of weird. The LinkedIn, the chat messages become like replies to the event or comments to the event. Test on LinkedIn. repeating audio. Okay. So we're going to continue. We're going to start the stream in like 4 minutes. I'm just making sure that everything is up and running. Looks like we got all 3 Twitch, YouTube, LinkedIn are all running correctly. If you have any issues with one of those services, you can go try one of the other ones to see if you get better quality. Hopefully the multi-streaming service works great. And if you're here, feel free to say something in the chat. I like answering questions or getting ideas for future projects or live streams. So feel free to say hi or interest and build off of that. And then on at 9:30 my time, I guess. So in like 3 minutes, we'll go into the content for today. And hello, LinkedIn. Thank you for the chat, comment, post. That's there. If you guys field any questions, I will be able to answer them during the presentation. The demo, because it's not really a demo today. Okay, start saying hi. Well, welcome to today's live stream. I'm glad you can join us. I am FPGA Zealot, or Andrew Wilson. Today we have a sponsored live stream from Altera. We'll be looking at their FPGA AI suite for the Agilex devices, specifically for the Agilex 5 today. One of the features we're going to be looking at is the AXI input and the AXI output that is available for the IP core. This will actually probably be a set of 2 videos. Today we're going to be focusing on the configuration of the IP core and compiling and adding it to a existing Quartus project for the Agilex 5 FPGA. We're kind of going to walk through the individual steps to demonstrate what errors you may see and how you can troubleshoot those errors. But thank you for joining us. Hopefully this will be informative, and so that we can take anyone's custom pre-processing, post-processing strategies for the FPGA, being able to hardware accelerate that, and be able to integrate that with the FPGA AI suite IP core. I am FPGA Zealot. We're currently streaming on YouTube, Twitch, and LinkedIn. You can also find me on X. You can also find me on LinkedIn as Andrew Wilson. A few disclaimers before we begin. This is a sponsored live stream. I am not employed by Altera. I do not offer official support for their products. The content on this channel is created for informational purposes only, and all opinions on this channel are my own. Before we begin, I just wanted to talk about the Altera Innovation Day that's happening next week in San Jose. You can find it on their website. I assume there's going to be a lot of good announcements of upcoming features and products that will affect the Agilex 5 FPGA and the FPGA AI Suite IP core. We'll be able to go over those updates in the next stream next week, or not next week, the future stream when that happens. I'm thinking like 2 weeks. And we can talk about kind of the updates from the Altera Innovation Day. So today we're going to be focusing on the Agilex 5 FPGA. Here is the development board I am using. I like it a lot. We're probably not going to actually use much of it today because we're going to be focusing more on how do I modify a project and build a project, use the AXI input and the AXI output features for the AI core. So the 3 topics we're kind of going to walk through over the next 30 to 45 minutes. We're going to look at the feature streaming, the input and output for the IP core. What is that streaming format? What's the data format for that? And how do we interact with it? So we're going to just jump to the documentation for this. So going to the 2025.1, the most recent version for the FPGA AI Suite reference manual. We're going to walk through this and look at where we can find the information for the features that we need. So first, we're going to look at the input streaming right here. So we're going to look at feature input and output streaming for the system. So this is an AXI streaming interface, not Avalon. This is an AXI4 streaming interface that allows you to input your input features and then collect your output features, or the output of your inference or your model that's happening in the IP core. There's a few different configurations. So there's a DDR3 supported configuration. I'm still working with a good example for that, but that will be really useful to look at in future videos. We'll probably look at the DDR3 and the DDR enabled streaming interfaces, but you can have streaming on the input, you can have streaming on the output. With the DDR enabled, you have your model sitting in DDR, but you can also have your input or output in the DDR or streaming. So there's a lot of different configurations that are very useful, and we can look at how you add these different ones to the architecture for the IP core. They have a little SVG file here. Okay. So this is focusing on the input streamer here and the output streamer here, which connects to the kind of the configuration network, and there's an additional layout transformer that's not, I think, in this picture. It's either in the input feeder or it's in the input streamer. I'm not sure where the layout transform happens. And this kind of just talks about how it works for the AXI stream interface. So we'll focus on the AXI stream interface first, and then we'll talk about the input and output data format. So I'm not sure if you've used AXI stream interface before, but it's a pretty basic interface. You have a ready and you have a valid signal. When ready and valid are both high, then then the data is moved in a single clock cycle. And so on the outside of your IP core, you basically have some type of logic that's waiting for the ready signal. And then when it applies the valid signal and the valid and ready are high together, you can do the valid earlier if you want. You can have valid lead. But as soon as they're both high, you're going to proceed to your next data word. Or data, it can be, I don't want to say word, it can be up to 128, 256, 512 bits per cycle. You can change the width of the data interface. And the output streaming is very similar. This does include a strobe and a less to help with indicating the end of the transmission. And I think these are internal signals. Yes, so those are internal signals. And that when you express ready and the system will do valid and you can collect the data. And the strobe tells you how many bytes are valid. There's clock crossing 2. So that's the AXI4 stream interface. This is quite common in a lot of other IP cores. And there are several IP cores within the Quartus IP catalog that supports this interface as well. So you can extend the AI IP core with the existing IP core also in the system. So next, to talk about the data format, we're going to go up to the input feature memory format. And we're going to talk a little bit about this. I really want to explore this next video. I'm getting a little bit more intimate with like how this data is manipulated, which is going to be critical for when we stream the data in and out. We're just going to kind of talk about that there's different formats, there's some nuances to how this data is used. But for the point of this is that there is it called layering? It's folding, I guess. We call it input folding. So there's an input folding process, and there's different formats you can do this at. And let's see if there's any good way from the final chunk. So they're using packed into CVEC size chunks. They're going this format, which is going to be batch, channel, depth, height, width, and CVEC, where CVEC is the fastest changing index, batch the slowest. And they have an example of the format here, where we assume this is the first one. Second one is over here. This is going to be 1, 0. Yeah, so this shows you kind of how it's formatted. But what we want to look at specifically is kind of the folding. So here, the data is folded into different channels. And it has the example here of the data and how it's folded appropriately. And there are different formats, and I want to explore these different formats and how they relate to input streaming in the next video. But there is no folding, where this allows for easier debug, but lower efficiency. You can also do folding entirely inside the FPGA AI suite. This is going to be using the input transformer layer. Right here, the transform mapping. So there's different mappings for the input transfer hardware. And this is, it performs the layout transform and the folding operations. So that allows you can get accelerated input using kind of raw video or raw stream data that isn't necessarily formatted the way you expect. And this is going to be kind of based upon your model. So there's going to be a little bit of a dependency of which model and data you have selected and shape of that input that you've selected. And we'll kind of go over some of these options as we move forward. Then just going to the output. And the output, there's options for slicing and with and without slicing. And you can kind of just see here in the array how the data is transformed. And once again, next time I want to dig more down into how we can process this data as it comes out. Okay. think that's most of the stuff. We have the different formats here. We have DDR3 and DDR enabled with streaming and utilizing the DDR memory. We have the basic adding AXI4 stream to the input and to the output of a model. We have the input format. There's the folding feature, which you can turn on and turn off, but affects performance. You can do it externally through your design, or you can do it internally in the FPGA. If you're processing raw data, it's really hard to attempt to externally fold the data before you give it to the FPGA, because you want the FPGA to get live stream data and not necessarily have a processor or system in the middle that's doing the folding for you. You could implement your own custom HDL to do the folding the way you want to do it if you have different methods, or if you want to just deploy your own solution. And then the output, with and without slicing, I should look into how you can change that format in the settings. Okay, so the next parts are going to take a little bit longer, but that was just kind of walking through the different formats. Now we're going to modify an existing project with these different architectural features. So the first thing we're going to do, well, something I've already kind of pre-done here, we're going to build off of the JTAG example that we did in the previous videos. So if you're following along and want to do this yourself, once you get the core DLA work environment correct, you can just run this command. It will produce the template, the default baseline project that we are going to modify. Okay. So you can run this, and this will generate it for any development board, right? So this is a super generic one. It's using JTAG. You just need to modify the clock, the DDR interface, and JTAG. You should be able to get this working with any board. We had a question from YouTube from Jim. I have some issues. Okay. For the example design on the AI suite, how do I revise them to run on the Aero Agilex 5 board instead of the Altera? Okay, so let's bring up the Altera or the Aero board real quick. We have some time that we can talk about this. So, Eagle Dev board. Do we have? So you have the Eagle board. So if we bring this over. Okay. So this is the board we're talking about. Okay. So this is actually very similar to the board I'm running on. It matters which example design you want to do. If you're doing an SoC based design, that's going to be a lot more complex, because you have to integrate with the OS, and that's a little bit more complex, the feature integrating it with the Yocto packages. If you want to do the JTAG only feature that we've been using here, it shouldn't be that hard. You just need to redefine the clock and redefine the DDR EMIF settings, and you can easily port the modular kit example design to the Eagle design. So that's mostly a pinout change. If you want to do PCIe, or if you want to do the SoC, those are a little bit more in-depth. The PCIe example design hasn't been, I think, implemented yet for the Agilex 5, and the SoC design is you got to make sure that your Yocto build matches with the modular kit. And I don't know, it's probably just like a slight device tree change, and you should be able to rebuild it. I have not looked into what device tree changes are needed between the modular kit and the Eagle kit. But that's a great question. Okay. Moving forward. So using that base design, the JTAG design, which we have up here in Quartus, this over. This example design, we kind of looked at his previous videos, but it's basically you have a DLA IP core like platform wrapper, and you have the system. So you have our system, our JTAG system, and this has a DDR interface. It has a control status register interface. It also has AXI stream interfaces that are currently tied low, and we're gonna change this by the end of the stream. But first we have to modify the DLA platform. And if you go into the files, if you attempt to configure this manually, it's not going to work well for you. You need to do this through the IP compiler tool. So let's walk through the IP compiler tool real quick. I think we want to use this one though. Yeah, this one. So going here, there is our command lines. So let's go through the documentation so you know where this is in documentation. So closing this, we go to the IP generator. We're going to the command line options, create IP commands. So let's go ahead, DLA IP, or create IP. We're going to do -- help and just kind of go over the different features. Let's close this, zoom in here. Okay, cool. Let me zoom out. Okay, so we're going to go through the different flow steps. Basically, we're going to list the architectures and add new architectures. And then we're going to demonstrate how we can update the project to target a different architecture. So to demonstrate this real quick, let's just add the performance core. So opening up here. So inside the DLA core directory, there are example architectures, right? And currently for the JTAG one, we are using the generic architecture. Well, let's say we wanted to do, let's do the small one. Let's do the small one with the soft max. So what we're going to do is, we're going to copy the file. And we're going to go to our directory here that we're working out of, which is going to be work build JTAG. Let's make a new directory, new folder. We're going to call it arches. And we have the softmax. So we've now added that kind of locally. So what we're going to do here is we're going to go flow list, so we just know where we're working. Let's actually do IP directory. And what we're going to do is we're going to target the core IP at the top of the build directory. And then we're going to do flow list. Okay, so we only have the generic core added at the moment. So now we're going to do flow add. And then we're going to go arches, that one. Sorry, I need to put in the correct command. This is going to be -- arch. Yay. So now if we do the list command again, we now have two architectures. And to demonstrate what happens here, so if we go into the core DLA IP core, we go into Altera, Verilog, and we do LSA. There's a bunch of files. These are all the individual files, but at the top, there's two directories. There's a generic directory and a small softmax directory. So now we've updated the core. How do we update the system? So the two methods to do this, or the two steps to do this, are actually really easy. So the first thing we're going to do is copy in the files. So what we want to do is go into our hardware folder. There is also a core DLA IP core here. We're going to update it. And now if we go into here, we now have the small softmax. Okay, the next step we need to do, we got 2 more steps. The next step we need to do is in the hardware folder, there is a DLA platform QSFP file. And here we need to go to small. We want to do small, what's it? And we want to do softmax. Softmax. Save that. And then we want to go to DLA platform wrapper. And this one is currently fixed to below this right here. So this is currently on the generic one. So what we're going to do is we're going to add the small softmax. And if we go here to the compilation tools, we hit analysis and synthesis, it's going to call that QSFP file and update the files accordingly. Now we have the softmax files here instead of the generic. And this is going to pull in all the appropriate configuration files. So there we have added a different architecture to the design with a few minor changes. We'll let that work in the background as we look in how we add the other configurations we need. So back to the input streaming, we're going to talk about how we add input streaming and how we can add output streaming. Go through the different steps and the issues we may see doing this. Okay, if you're joining us, thank you. If there's anyone in the chat, there's some redacted messages. Okay. Let's see. Welcome to the stream. If you're just joining us now, we are looking at using the Agilex 5 and using input streaming and output streaming. We looked at the documentation, and now we're modifying the architecture to do input streaming and output streaming, and how we add this to our FPGA design and Quartus project and build it, and what some issues that we may see on the way. This is a sponsored Altera stream. I'm FPGA Zealot, and if you have any questions, feel free to say hi in the chat. Okay. Okay, I think we got everything. So to add the interface, we're going to parameter group. And this parameter group has an example right here where we want to add the input stream with a depth, a width, and a depth. And we want to add this to the architecture file. So let's go ahead and do that. Let's see what happens. So we're going to go here. We're going to copy the generic. We're going to go to our little target arch folder here and paste. Let's rename this to streaming. Streaming. Okay. Click on the Quartus project. It's synthesized just fine. So going back here, let's go back to the main directory, and let's go ahead and do the list, and let's add streaming. Okay, we're going to try to add the streaming architecture. Oh, we didn't modify it, sorry. So going back here, we're going to copy this, and we're going to add it to our streaming architecture here. Let's just go ahead and do that right here. We're going to add the input streaming interface. And now we're going to re-add it. And here's a critical setting that is required. To use input streaming, the layout transform hardware must be enabled. So let's go and pick something out. There's a lot of different configurations depending upon your input size. We're just trying to do a generic one, so we're just going to copy it from an existing one. If you want to figure out more of the settings, we can go here to this parameter group, and this kind of talks about the different settings that are available. But for now, we're just going to go to the DDR-free ResNet one right here, and we're going to copy this layout transform in the DDR-free example for the Agilex 7, and we'll just copy that over here. And we can try to add this again. Okay, we've now added it correctly. If we list it, we now have all three. So let's go ahead and copy what's in the API core, Altera API here. And let's go put that into our hardware, Cordella here. And let's just make sure that it works. Okay, now we have generic, small, softmax, and streaming. So let's go ahead and try to build the streaming. We're going to have an issue, and this is not a well-documented issue, so I want to walk through this with you guys. So to update this, we're going to go back to here, go to our DLA platform, and we're going to put streaming right here. Go back to our wrapper, put streaming right here. Okay. The tool should be upset at us. Maybe they haven't refreshed yet. So if we run this, the QSF file should be pulling in the other one instead. Okay, yeah, now we're pulling in the streaming IP core. Let's bring up the error. Okay, there, we saw the error. That was really quick. Good, good, good. You're going to see this issue, and you're going to be like, what's happening? Why is this not working? So the best thing is to actually go to this file and look at this bug, right? So I think if we double click it, we should go to it. There we go. So right now it's saying that the index for config ID layout transform is -1. And you're like, well, that's not good. We need a positive index between like 0 and 255 or something like that. And if you try to go into the core DLA here, and we just run a grep off of this configuration, we can see that in streaming that the layout transform is -1. So if you come to this issue, it needs that the configuration doesn't have an appropriate index for that module. And I don't think it doesn't really talk about this here. And it's related to the config network. And these parameters define the configuration network that connects to components. Typically, the section is changed only minimally when modifying the examples in the architecture. So there's not a lot of documentation about this, but let's go look at the other examples of what we need to do. So if we go back to this ResNet version and we go all the way to the bottom, we have the config network here. And right here, we can see that there's a layout transform. It's not an input streamer. I don't see an input streamer here. But there is the layout transform. I don't know if we need to put the input streamer here as well. Let me see output. Okay. There is an input streamer setting as well, and we'll probably add that. I'm going to have to, I need to find the documentation that explains what the input streamer is actually doing here. So we're going to go ahead and add the layout transform, and we'll add the input streamer as well. So in our version, we have to go back to our architecture. Not the streaming one. Yeah, here. Go down to the bottom. We don't have any, we have a softmax. We don't have, we do not have any streamers. So we're going to add the layout transform, and let me go to my JTAG example and look at my architecture that I got working. There was a input streamer module as well. We'll try that real quick. I'm not sure if it's necessary. I'll have to get that information later. Let's go ahead and make it look the same as everyone else. It's something I'm going to have to figure out. So adding these to the configuration network, we can then rebuild it. So we're going to go here. We're going to re-add it. And we're going to copy over that stuff again. We've modified it. Now we go back here. This should actually synthesize correctly. Okay. While that's building, let's talk about the DDR3 examples real quick. If you do try to build the DDR3 examples, they have this feature at the top, which is called Enable Parameter RAM. And this is basically, instead of using DDR for your model, you're using local memory for your module. And important settings, this is just kind of a thing when you go to create the IP core here, right? You need to have the parameter ROM, the memory initialization files already created. So when you do DDR3, you actually have to make the architecture, build the model, create the IP core, and then bring that into your design. And there are some little tricks to modify the MIF files more dynamically, but for now that's kind of the flow. I don't have a really good DDR3 example for the Agilex 5 ready, but hopefully next time we can look at a Agilex 5 DDR3 example and how we bring in that parameter ROM into the device. So this is building. So we're going to kind of move on to our next step. But let's go ahead and answer some questions. So Jim, out of the YouTube chat, also had another question. Jim, you asked about transformers. So there is, kind of rolling back, there are a lot of models that the DLA ecosystem can support. So you can bring in the Onyx model and test it with the tools without a license and see what models work. Currently, the transformer layers do not work with this current implementation, but there are upcoming updates later this year that may change what features are supported within the tools. But right now there are no support, there's no support for the transformer layers. But you can run any Onyx model through the DLA tools to see what is supported and not supported on the FPGA implementation. You can also look at trying to doing a heterogeneous system where you do some of it on the FPGA and some of it on the CPU or GPU or something like that. So you can look at doing a more complicated heterogeneous system. But hopefully that answers your question, Jim. Okay. So going back, we're going to this slide. We're going to be looking at how do we update the system to connect to AXI Stream. If you're kind of used to a Quartus project, this is not too bad. If you're more of like the AI model person, opening up the System Explorer and selecting IP core may be a little new to you. It doesn't take much time, and we hope to try to get done in like 10 minutes, 10-15 minutes, and demonstrate how we connect this to the system. If you're joining us at this 35-minute mark, thank you. We're doing a sponsored Altera stream on adding streaming input and output to their FPGA AI suite tools. And I am FPGA Zealot. Feel free to ask questions in the chat. We are on YouTube, Twitch, and LinkedIn. Okay, so the next part, we're just going to open up this shell queue system, and we're just going to add some DMA cores and then hook it up in the HDL. Give it a moment. Okay, so if we want to look at the schematic view real quick, schematic view. This is bringing in the JTAG interface right here, and the JTAG over the master bus is able to talk to the DDR, is able to talk to an AXI timer and to the control status registers here. Other than that, there is a data bridge here coming from the AI IP core that is going into the DDR interface. So what we're going to do is add some scalar, gather, DMA cores. I want modular. And we're just going to add 2 of them real quick, and we're going to do 100. Well, we'll add 1. We'll do the input. We can look at the output either on a later in the source code. I can demonstrate how to do that in an article later or in the next video. So we're going to do memory mapped to streaming. The data width is going to be 128. That's fine. That's fine. Aligned access only. That's fine. Let's not worry about bursts. We don't need extended support. We don't need packet support. Okay, let's finish this. So we need to connect this to clocks. And we basically want this to work off the AXI4. So let's go ahead and use this clock here that's on the data bridge. So we'll go grab that one. And which reset is the other one's doing? So we want to match what is on this EMF data bridge. So we want to use this guy right here. It's coming from this cal done. So let's go ahead and put the cal done as the reset. Do I need to? I think I need to change that. Okay, we're going to connect this to the JTAG master. So going to the JTAG master right here. That's this guy. I had those there. We'll map those in a second. The memory read is going to go to the AXI4 bus here. And then we're going to make this external. And we'll go through the air real quick. Connections, export external. And we're going to go to assign base addresses. We're going to have this issue right here. So this is saying is outside. This is since it's an 8 GB memory interface. So you need 33 bits, but the addressing on the DMA is only 32 bits. We need to do what's called a bridge or a JTAG address extender. So we want to duplicate this. Yes. Down here, we're going to rename this, and we're going to call it rename. We're going to call this DMA. And we're going to do the same clock, the same reset. And we're going to take this off. We're going to go here for the read for the Windows slave. And then we're going to do this for the AXI master. And we can go ahead, reassign base addresses. And now we just added a DMA core. You can look at the addresses for each of the interfaces here. We want to make sure the JTAG master one didn't change. DSR, data bridge. I think that's all we need. That should be fine. And then we go back to the schematic view. You can now see we have a here where the DMA core over here. So we have a DMA core that's going here to read the data. The data comes back here, and then it goes out to the data. So we can go ahead and validate the system. And then we can generate the HDL. Yeah, go ahead and generate this real quick. Shouldn't take too long. Then I have to go find the output example for that. Okay, there you go. Just adding DMA real quick to the system, and then we're going to hook this up and build it. Okay, we completed. Let's go ahead and close this. And if we go to top, we now need to add the AXI stream interface here. Okay, so if we go back to where we have our Q system output right here, if we go to where? Okay, here we go. This is what we want. So in this instantiation template, now we're just going to add these here. We need to set this to 1. It looks like for the reset that needs to be set to 1 for the core to come out of reset properly when you enable the input. So okay, and now let's connect these to this interface down here. Grab this data, and this is going to be ready. Oh, here. I think there's only one more thing we need to change, and that we need to hook up the clock. So right here we have an AXI clock set to 0. We're just going to use the same as the DDR clock. Okay. And we should be good to go. So let's just go ahead and run synthesis. Okay, we kind of got to the... Oh, sorry. I probably am not talking loud enough. I'm mumbling to myself. So, if you have any questions... Oh, we have an error. So let's go fix the error. Let's fix this error. Let's go here. Okay, I did not instantiate valid correctly. Okay, where did we do that? We just did data again. That should have been valid. That's valid. Let me turn the mic up a little bit too. Okay, that's probably better. So we just went through and modified the system to add input DMA. We connected it up to the IP core. So next video will actually demonstrate the data flowing in and flowing out with some simple Onyx models, use some real models and maybe some real data. But I really wanted to show how I go from an example design to my own custom design. I like this JTAG example a lot because there's a very basic top level that divides the AI DLA IP core from the custom system. So you can replace the shell with your own system and be able to handle the input, the output, and the data bus and the configuration bus as you see fit. You can load in a soft processor like Neos 5. You can load in any type of system or use the hard processor. This allows you to, I don't know, in a traditional FPGA approach, be able to connect the AI accelerator to your custom logic. The next thing is just configuring the AI core to use the streaming interface and to configure the data and process the data correctly. Which we don't have time to talk about today, and I need to prepare really good examples so we can walk through these different situations. Is the audio working better now? I haven't really got anyone back from the audio. I just need to constantly talk, put music in the background, or something like that. Thank you. So we're kind of getting close to the 50-minute mark. We can go ahead and start the fitter, and we can let it build. It's going to probably take 10 to 15 minutes to build, but we'll probably have to end the stream before that happens. But hopefully I was able to answer some of the questions of like, okay, this AI core sounds really cool. How do I connect it to my system? It'd be really useful to demonstrate this in simulation and hardware going into the future. So that I want to be able to help you be able to connect this really awesome solution to your custom HDL. Okay, synthesis finished. Let's see if we can go look at the reports real quick. So in synthesis, we have logic utilization, IP core summary. Where is the report I am looking for? Resource usage summary. Okay. Oh, I have. Oh. Okay. There we go. Yells. DSP blocks. How many are we using as? Okay, we're using 32 with the new DSP configuration. Here's the breakdown of the cores. Okay, that's really all we have at the moment. So we have a question from Twitch about the utilization of the IP core. So that really depends upon your architecture, right? So if we go into the architecture real quick, we have like a small, generic, and performance, and I have seen these very widely in utilization. I think for this one, the generic, the small is rather like, was it a half, a third of what is available in the Agilex 5. I'm sure with like the Agilex 3 coming out, there's going to be even smaller models that have been kind of optimized for that smaller platform. These DDR free ones use like almost all the local memory to bring in the model without using DDR. The performance ones can easily double, triple, quadruple in size depending how much you put into the layers. So there's a lot of configuration you can do with these architecture files. And it's very easy to modify an architecture file, to update your Quartus project, and to build it, look at the utilization, and see what you're expecting. Thank you for the question. Any other questions from YouTube, Twitch, or LinkedIn before we call it a day? I really want to get this working in simulation hardware next time so you can approach the integration from a more traditional FPGA approach. Okay. So, feel free to like, subscribe, follow, whatever you feel comfortable. Yeah, I like sharing this information, and being able to reach a greater audience, to get better feedback would be great. We also have the Altera Innovation Day next week. I'm really excited to see what new updates are posted, and we'll be able to talk about those next time. We want to look at how the model dependency is for the streaming inputs and outputs. I want to be able to build some very basic Onyx models that work for streaming, like a bypass, a truncate, a simple convolution. Be able to maybe run those in simulation, run those in hardware, do a classifier for live video, and of course provide any fun updates for the Altera Innovation Day next week. Thank you for coming. I really enjoy presenting this data. It forces me to kind of approach these new features, to dig down into what the FPGA tools are providing. Someone definitely subscribed or liked or something. I got the update. There's a lot of different FPGA tools and vendors, and these live streams force me to really dig down and be able to teach the material. And if I teach the material, I have to be able to go through the documentation, through the build order, be able to modify it, and be happy with what I can deliver so that I provide a useful experience. So thank you for joining me this time. I will leave the stream up for probably 2 to 3 more minutes, just in case anyone posts any last minute questions. And once again, thank you. Okay. Thank you for joining us. This recording should be on LinkedIn, should be on Twitch for like the next 30 to 60 days, and it should be on YouTube for until I take it down. So feel free to rewatch it, to post questions to those different sites. You can join the Discord channel. I will have an update when I have the article in the GitHub repository correctly updated, so you can follow along better with the source code. I do hope to have, you know, end-to-end examples working before I post the article and the source material. Well, I look forward to next time. Let's aim for 2 weeks, maybe a little bit longer to get the example ready. But thank you for joining me today. Goodbye.